Hey guys, we are recording this session. I just started recording. Just check if you can see the recording actually active, and also if you can hear me and and see my desktop in a few seconds, like right now. You should see my desktop. Do you see it?
Everything looks good.
Awesome. By the way, I want to check one more thing. Do you have access to the to what? To the third segment, which is what I wanted to check. We want to start cloud architecture discussions today, and I want to make sure, double check that you have access to this segment. Do you?
Let's see. Oh, I need to log in.
Yeah. You need to log in. That is correct.
Yep, looks like I have access.
Okay. Okay, so I think we should be good. Bunch of people are not going to be here, it seems, today, which is going to be a very small group that we have. So that's actually a good thing, because what I can do is fine tune to what you need as opposed to whatever I think you might need. And so, in fact, this architecture segment that I'm going to begin today, we keep it a little bit flexible for a purpose. Is that what we want to do is to make sure that we are catering to your needs, as opposed to, let me tell you what I have in mind and what I want to cover in this segment. But I would like to make sure that I give you the option to pick and choose, because we have way more content that I can actually fit into the bootcamp. And that is what I wanted to make sure that I give you a complete overview of what I have in mind and what we intend to cover. But again, I am flexible, which means you choose. I don't need to. You decide what we want first and what we want later. And then depending on the time left, we have only 8 sessions left. So in that time, I want to focus on what you think is relevant to your case in your business, in your company, in your project that you're doing with. And let us focus on that instead of whatever I come up with as my crazy idea of what you think I should do. I think is more rational approach. So let me describe what I have in mind. Let's begin with that. So in our 3 segments that we have, we focused on horizontal, the breadth approach to understanding, infrastructure as a service, platform as a service, and some software as a service. We focus primarily on compute, storage, and network capabilities, and some aspects of platform. Not much here. We did not do because it is trivially simple. So we skipped that. And then we went ahead and did a bunch of chef. These are depth-focused sessions. So it's deeper as opposed to breadth. So we did a bunch of Ansible also. And we started playing with Docker containers. And I want to go deeper into Docker in the architecture segment. But the way I would like to actually make use of our time is to actually also not only focus on cool technology that keeps on coming. For example, Kubernetes, which is something that I think is pretty cool and pretty useful. So we will cover that no matter what. But more important than that, what I also want to do is to cover case studies. Case studies of actual companies that are making use of cloud technologies, specifically the horizontal breadth coverage available in the industry, and using some of the automation techniques like Chef, Ansible, other Docker, some core capabilities to see how companies are actually implementing and solving their problems, solving customer problems. And that is what I want to focus on. So what I would like to actually do is, in this segment of architecture, focus on understanding how actual companies implement and solve their customers' problems by using the cloud. So using these two things, we'll apply that to a real case scenario of a specific company. For example, I would like to talk about the Netflix company, which is one of the first companies to completely go 100% on cloud, totally. In fact, today they don't even have a data center. All they do is strictly on the Amazon cloud. And how do they operate? What do they do? What is their business? What is the customer? What is the customer problem? How do they actually solve that customer's problem? How do they go about implementing that detail? That requires a comprehensive depth of understanding of the Netflix company's business and understanding how they actually pull these things off together in running it on the Amazon cloud. What do they need to go through? In what kind of motions, what kind of tools, what kind of techniques do they apply? And then implement what you and I already know as what we call the Netflix app. But it's available on this website. I think you have an account. Most of us have an account through our phone companies these days. Most phone companies are giving us a login, and here you can just log in. Now, what I will not be able to do is actually play a video, because that will be a problem, because it will become a copyright violation if I actually become and play that a video. I will not be able to play any video, which is, I hope you understand. If I play the video, then it becomes a copyright violation because I'm recording it. So I will not be playing. Having said, you'll be able to examine what the site is doing, and understand its capabilities. And this is me watching, and there are some you've seen it. This is not new to you. So bottom line is, what I want to focus on is not the front end, but the back end of what Netflix does. Understand how they actually implement cloud technologies to deliver the experience that people expect. You expect, I expect. We have Netflix, on the phones. We have it on the car. We have it on our televisions. We have it on our desktop, laptops, all these places. We have certain expectations that we have built up with the Netflix as a company. So what are those expectations, and how does the company solve that customer's expectations and actually provide a good solution to that user's experience? That's, I think, what we will focus on. So that's one case study. Like that, we have more. We have a ton of them. But again, it's up to you to pick and choose as to where we focus on, attend, and spend our time on. That's one big bunch of what I will call work items that we can focus on, case studies. Another thing, if you go look at, and I'm going to give you links. Links are coming in Slack chat. These links are actually the work that a bunch of our big cloud companies have done a great amount of work. And actually what they have done is made my life a whole lot simpler. The way what they have done is, if you look at, let's say, AWS architecture. AWS has a complete website dedicated to application architecture. And here you will find that they have a ton of videos and a ton of documentation and ton of resources available for us to use. There are some beautiful illustrations of how to do things, or rather, what they call reference architectures. So here, Microsoft Link Server is one example. By the way, this is one of the products that I used to work on in Microsoft before, so I know that quite a bit. This is basically my puppy. And so that is one of the recommended ways that Amazon will provide you. How do you want to run Link Server for your company? So this is like a variety of situations here, variety of applications. How do you want to run SAP in your company in the cloud? And these are some certain specific examples that Amazon has put together in terms of what is relevant to customers. And they are giving us, or rather everybody, what they call reference architecture. How to do the right way in Amazon cloud. How to do X, Y, Z, whatever that thing is. How do you want to do this on the Amazon Web Services? that's what they are defining in this documentation. A bunch of docs available in the Architecture Center here. And so I'm going to give you a link, and the link is coming right here, right there. And like that, there is Microsoft also has done similar great amount of work. Microsoft, and then what was that? Architecture. Architecture. They also have a fabulous set of resources right here. And they also have some beautiful illustrations and pictures as to how to implement a variety of examples. So for example, this is the example of live streaming digital media, which is kind of sort of what we just discussed briefly, or at least mentioned briefly, is about using the Netflix as an example case study, which is what Netflix does, live stream of digital media. It may not necessarily be live, but it is definitely streaming digital media. Live means, do you know what live stream and regular streaming media is and what the differences are? I hope you know. So the idea between a live stream is something that I am doing right now. I am streaming my video to you. That is a live stream. Whereas, this is a streaming video of somebody doing something. I don't know what will pop up, but there's going to be some video pop up on YouTube, and that is a streaming video, but it is not necessarily live. There are videos, and they're available for us to watch, but they're not live videos. The one I am sending to you, that is a live video. And that is the difference between a live stream and a regular stream, which is like a pre-recorded stream. Basically, this is on-demand streaming versus live streaming. They operate kind of sort of similarly in a way, in that in a live stream, there is a live source like that. There is a camera. Whereas in a streaming media, like in a on-demand pre-recorded digital media, there is no need to have a camera. You can still have a camera, but there is no need to. And that's the difference. But this is a picture implementation of how do you lay out an architecture using components available in the this is Windows, Microsoft Cloud. Similarly, if you look at this sheet of paper, which I'm going to pull up, and I have actually downloaded a bunch of architectural diagrams from Amazon, and here are some illustrations. There are quite a bit of them, and I have saved them locally because they become hard to find in the Amazon website sometimes. I'm not able to easily locate that in here. So maybe they are locatable by doing proper searches on the AWS website. You can probably find them as a reference architecture. AWS reference architecture, if you go look at that, they should bring up something. No, I did not search properly, I guess. So I will do that again. AWS reference architecture. Let's see what pops up. Yeah, things have changed, but no worries. I have it copied here locally in my computer, and I will be able to use these as illustrations, and I will pass it on to you so you can easily read it. So here is the one thing that I will be using as an example to discuss the implementation of what we would think of as, as a reference architecture, as to how Amazon recommends that you set up if you want to set up your own Netflix, or rather just sharing media. That's what the idea behind this particular piece of paper is how would one go about using this Amazon technology to implement media sharing capabilities in your company. That's how this picture tries to illustrate. and I will pass it on to you in a PDF file, just like that. I'll copy it and drop it into Slack chat, so you have it, and that should be coming to you soon. So if you're able to find it yourself in Amazon, I think that's a better copy. But I have like my hand notes on top of it. That may be a little bit. I like to clean it up before I send it to you, and then I'll send it. That makes it a little bit nicer. So I have this link here for some reason that I need to remove, and then I send it to you. So here we go, PDF export, and that should send a PDF out to me on my desktop, where I can drop it and then grab it. Come on, PDF. Well, we'll get to the PDF. I don't know where the PDF went. I was expecting it on my desktop and it's not there. I was expecting it right here. It did not come, but don't worry. No worries. The point that I want to focus primarily on right now is to make sure that you are with me when I say that we want to actually understand what do we want to discuss in our, where is that? I think I missed my sheet of paper. Yeah, this is the sheet. The core thing is that you want us to focus on whether you want to go further in Docker and container technologies. So focus on Docker Swarm, Docker and Kubernetes, or focus on understanding running actual live applications in the Kubernetes clusters that you will create. Understand how do we set up our own Kubernetes setup so that you can then use these as a place to run containers in a sophisticated manner, like how big companies are doing. And then there are more case studies. Another case study that we will actually have a combination of Kubernetes together with a case would be the example of an application called Pokemon Go. If you know this game, which you may have seen or played already, Pokemon Go. Now this game that I suspect you may have seen or heard of or played already, but that Pokemon Go is actually runs in Kubernetes. And you will say how exactly, and that's the way I will describe as to how and where. And so the idea is Pokemon Go runs on the phone, right? It runs on Android phone or iPhone, but on the back side of all this, on the cloud end of all this Pokemon Go is a Kubernetes cluster. Actually, it's a bunch of other things, but it is running on a Kubernetes cluster in the Google Cloud. That's what this particular discussion is describing to you as to how it runs, and I'll further elaborate on how they use this company behind Pokemon Go, which is this company called Niantic, which is this organization. How do they use Kubernetes in the Google Cloud to run and get all of us to play Pokemon, which I have played like twice, and I lost all the Pokeballs, and so I ran out, and I don't know where to get them. So I don't have any, so I don't play it anymore, but it is extremely popular game. It used to be, at least. If you look at the iTunes store or Android store, it used to be like a top number one downloaded application, I think the last year, or maybe year before last. I don't know when it was, but it has been a fairly immensely popular application that people have used and enjoyed. In fact, there are cases of examples of people, Boeing employees specifically, using this Pokemon Go app right inside the Boeing factory. And Boeing had to call Niantic and ask them to remove these Pokemons, wherever they were inside the factory area, and put them somewhere outside so that the workers on the factory floor can focus on, not on Pokemon, but on the work that they're doing. That has been the case in which, by mistake, or I don't know how, but Niantic company decided to place Pokemon Go right inside the factory also. They just spread out. And this is, by the way, geopositioning of fictitious. I hope you know what I'm talking about. If you don't, please tell me. But we'll talk about this as a case. So bottom line, if you look at what I just discussed and mentioned, we have to cover technology like Swarm and really understand it. You have to understand Kubernetes. How do you not only implement and get it up and running, but also use it, these two things specifically, to implement it in the context of a cloud, to use this in the context of a cloud for running real applications that you choose, and you will then be able to run it for real, for your usage in your company using these technologies. And you get to choose which one is better for your case. And you can actually choose both because they're free, they're open. So you can implement, pick and choose one technology versus the other depending on a project of your consideration, and we can help us. I can help you in picking a pros and cons of these things. As to, it really boils down to the application you have in question, and that's what will effectively help you in making a decision between this versus that versus something else. And one of the recent evolutions that has happened in the context of these things is that the company I was mentioning about, Netflix, they have managed to open source their own orchestrator. Just recently, like 3 days ago, orchestrator. Their orchestrator, they used to run their own, and now they have it open sourced. It is, I think, called Titus. It's a new orchestrator out there available on GitHub. It is from the Netflix company. So let us see Titus orchestrator. See what pops up. There it is. So April 19th, Netflix Titus joins the container orchestration arena. That's the news. And well, Google came out with its own Kubernetes orchestrator, and here comes Netflix with Titus. And Titus is Netflix's open source, meaning right here, and it is available Netflix Titus. And this is the Titus documentation link, and the APIs and source code and all that are available. And you can get to the control plane and the executors and all that. And we will understand these things also, but it's fairly new. I haven't actually played with this because it's like really, really new. New as in new to us. It is not new to Netflix. Netflix has been using this for quite some time, ever since they have been evolving this underlying platform, and they recently decided to open source it, which is a very nice thing to do, right here. So we can see if it is good for us, and if it is good, we'll use it. It's open source, right? Now it is open. You can download it, play with it, delete it if you don't like, all of those things. So that's, new things will keep on popping up in the industry, in the arena. You will see that happen all the time. We will also, what we will do is go back to what we discussed in the first segment and in the second DevOps segment, and attempt to automate end-to-end using more tools, such as a tool called Terraform, a tool called CloudFormation. And what these tools do is they will help us create a architectural blueprint in a cloud of your choice based on a Git repo. So you put your things inside a Git repository and you run this Terraform tool, and what it will do is actually implement not only all the nitty-gritty details like subnets, NAT devices, and public, private, in routing tables, and all that thing that we discussed and did by hand. We'll be able to see all that thing automated, and not only that, we'll be able to run real applications in the context of that design, as long as you are able to put that inside a Git repo using any of the automation tools that we have used. And so as long as it fits into the repository, this tool can take a repository and create a real application functioning in a cloud of your choice. And you will see those things where you actually provide what I will call, let's put it this way. So you have some cloud and you prepare your application to somehow make it run in the context of cloud. Now that becomes a very, very tedious and difficult job. So you want this to be able to reproducible. In another cloud, the exact same thing should be reproducible with ease. And you can do that. Once you have this reproducible in form of a Git repository, you can then reproduce this exact setup in this cloud location. You delete the whole thing and create it here. And that is possible. It takes a few minutes, maybe a little bit more than a few minutes. But you will have the exact same application running in that cloud that you decided for. And that will become easy as just running one command. And you have the entire stack, the entire design, entire architectural blueprint, along with your applications up and running. And that's the kind of experience you'll be able to see once you run these kind of tools, which we'll also cover, which will help us understand and realize complete end-to-end application deployment, including not only the boxes, but all the way down to the bare metal, the nuts and bolts, the subnets, the NAT devices, the security groups, the route tables, finer details, all the way to that level of depth. We should be able to see those things. And then we'll also have case studies to discuss along. So we'll mix and match these things together. The three case studies I think I have in mind are Netflix, the Pokemon Go, and another new case study on X.AI. I don't know if it's interesting to you, but this X.AI is like Siri, or think of it as like a virtual assistant. I think that's a better way to say virtual assistant. So we'll see what it takes to run a artificial intelligent virtual assistants in the context of using this service. And we'll see what they have done in the Amazon cloud to implement. That's a decent service, by the way. If you haven't played with X.AI, I suggest you should play. This X.AI is basically a personal assistant for you. There is this thing called Amy, and I think that's the email address for Amy. So you just email Amy, and she's your personal assistant, and she will help you schedule and do your thing she'll basically manage your calendar. There is no person, by the way. It is a fictitious person called Amy. And so you just email Amy, and she will respond to you in natural language. Let's see if I have some examples to show you that will help you understand what I'm talking about. Amy. And so there is Amy Ingram right there. So she is not a real person. She is a bot. So you can ask Amy to schedule a meeting, something like here. So I send an email to Amy saying, hey, Amy, can you please schedule a meeting with David? That's what I asked. Can you please schedule a coffee meeting with David? And then that's it. Then I went and had coffee with David. She did the rest. And so David actually on the other hand, responding me here. This is what I sent her. I know David is my friend, right? I'm playing that scenario with him. And so David says, this is what I sent her. This her is in quotes. And so this person, this fictitious person, is actually interacting with David, trying to schedule a meeting as if she is a real person. But it is not. She is not. She doesn't exist. Amy Ingram is fictitious. And so she's been interacting with David, and she finally was able to get an appointment. The appointment showed up in my calendar, and yes, I did go to meet with David and had my coffee with him. So that's how this thing works out. That is another case study, and we can come up with more cases if you are interested. So my question to you is, do you have a preference of one type of discussion versus the other? Do you care? If so, what do you care for more? That's the real question I want to ask you, because I can tune and adjust our program to meet your needs. So the real bottom line question is to you guys who are here right now with me, tell me, what do you need? Or rather, tell me which one should I do first, so we can adjust. Do you want to discuss the Netflix case study at least today, and maybe move on to more tools like the Swarm discussions and actually running a real application in Kubernetes, implementing that the hard way, implementing it the easy way, and then running a real application on top? Understanding Terraform, is that the area of your interest? Or what is the area of your interest? That's what I want to ask you. So we have so much more content, and it is available in our website that you have seen already and you have access to. But again, I need to customize it to what you want or expect from the program based on what you think is more relevant. And if I don't hear an answer, that's okay. Because what I am going to do is, I'll just told you, I will begin with Netflix discussion and we'll move on to tools. That's what I think I will do. But again, you have the flexibility to change what I want to cover, what you want me to cover. So we'll go accordingly, unless you stop me and change my direction. And that is totally welcome to change my direction, because you drive. I will guide you, but you are the driver. So having said, let's understand from a top level perspective, what exactly is architecture? Like, what are we really talking about? We are talking about all things that are necessary to implement a solution for this guy. Who's this guy? The customer. And so we can call it blueprint, we can call it architecture, we can call it whatever fancy names we like, but essentially this guy has a problem and he is willing to pay us money to solve the problem. So they're looking for a solution. So whatever it takes for the problem to be solved, whether it is hardware, software, services, or anything else, whatever it takes, it may not be hardware. It may be something else completely out of the blue. That has nothing to do with technology. There may be cases in which you might be meeting a customer that doesn't want a technology solution. They just want a solution. So as long as you're able to solve them, they will gladly pay you money. So that whatever it takes to implement a solution, that's what I call the architecture of the entire, the blueprint of the entire solution, that you go about, build it, run it, you incorporate hardware elements, you incorporate cloud service elements, you incorporate software, build some software. And in fact, when you do these things, there are again three things. You either build it yourself, or you buy some software, or you partner with somebody else that has the software already. And then you put these things together to create hardware and software and services together, these three things together to basically put together an architectural blueprint to solve the customer's problem. That's what I think architecture really boils down to. However, if you ask any company or any other person, they will have their own definition of what architecture means. And many of you in the Boeing company are cloud architects or architects. So you know architecture better than anybody, because you are the architect. I am not. I'm a trainer. So let's see what Wikipedia has for us. What is architecture? Architecture. So let's see what the definition is. It's a general term to describe buildings, products, planning, construction, blah, 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 whatever. But that's their definition. What we want to do is not focus too much on the definition part, because that's kind of boring. We'll get to some examples to talk something of meaning to a customer scenario. So we'll talk about Netflix as the company as an example case study that we want to begin discussing, and for which I need to pull up a bunch of things that I have on the website somewhere here. So let's go there to the website where is that? Here. And we should be able to open up some reference material that I have stored already. And these are going to be handy, but mostly there are a few pieces of paper I want to just quickly refer to. And then I'll start discussing I'll start mostly using whiteboard to help you understand. But what I'm trying to take you to this location is where you will have By the way, there are some things I want you to do on your own. For example, there are some videos here. These are pre-recorded videos, cloud services architecture. I must caution you that they are kind of old, like 5 years old, probably 4 to 5 years old, these guys, these videos. So I would like you to watch them, but with a pinch of salt, because they are old. They're still accurate, nothing wrong with them, but they're boring. I'm being honest. They're boring videos. I mean, they're like 20-minute long. Yeah, there it is. See that 20-minute long, and in a pathetic voice, this guy, Nilesh, is talking to you. So, and you know, I used to talk like 5 years ago, the way I used to interact was boring. I knew that. But I had no other way to do but just to begin somewhere. So these videos are actually pretty darn boring videos. I must caution you that. But still, if you find some time and you're feeling sleepy, maybe it's a good idea to watch them at that time. Okay, so there are 3 videos, pretty boring. Give it a shot. Don't like it, skip it. No worries. This video is not that boring, the second one. And we will actually discuss this, but I'll not play the video. I'll instead discuss the concept. The third one is kind of sort of okay. And yeah, you should see if you like it, watch it, otherwise skip. Moving on. What I want to do is actually discuss the Netflix case study. And what I want to focus here on is a bunch of pictures. The pictures are opening up, and I will now discuss the Netflix company as an example of somebody who took their business of sending DVDs in the mail that you know already. You know, they used to send these DVDs in the mailbox. There used to be a red envelope that you may have seen that looked like this. And they will send it to you. You had the ability to select, I think, there used to be like long ago, there used to be a thing called the queue. In that queue, you will have items listed as your desired sequence of movies you want to watch. And you will list your movie number 1, movie number 2, like that in the queue. There used to be a website like that maintained the Netflix queue, and you have your desired sequence. This is the first one you want to, or the very next one you want to watch, and like that. And they will find that this movie becomes available. They will mail the DVD to you. And the DVD becomes available in your mailbox. You watch it, and then you return the DVD in the same red envelope. It goes back. That used to be the business. So it was basically a physical business of physical shipment or rentals, I should say. Physical rental of DVD. That was the business. Now, if you see the evolution that the company wanted to do is from DVD in the mail over to streaming from the cloud. That's the evolution that they wanted to accomplish. So now, at the time when Netflix had this idea of sending out this red envelope, what they used to really do is rent DVDs, and they were competing with, do you know who? Do you remember? Are you there with me?
I was going to say Blockbuster, but you already had it written, so.
Yeah. I was expecting you to finish my sentence. So Hollywood Video, and those guys existed. You know, these guys are probably still there in Alaska somewhere. I don't know. I heard somebody the last time told me that there is still a Blockbuster in Alaska. Fine. And there is Hollywood Video and all that. So these guys essentially died off. You know why they died off? Why these guys died? There are a couple of reasons. One of them was the late fee. They used to charge an arm and a leg for the late fee. If you are 1 day late, Blockbuster will charge you $19.99, some obnoxious number for late fee. That is exactly what these guys did not. No late fee. And do you know why they were able to get away with no late fee at all versus these guys had to charge a late fee? What was the reason? So on one hand, you have Blockbuster, and on the other hand, you had Netflix. These guys charge late fee. These guys charge no late fee. Why? Why were they able to do that? These guys are charging like $19 if you're 1 day late. And here they say, you know what, return it whenever you feel like. When you return the first movie, we'll send you the second one. That's how the game was. And there is always a queue. And you accumulate a list of things that you would want to watch in the queue. And then you just return this one, then you get the second one. And then sometimes you have a bigger plan. You can get a two at a time, three at a time, like a bigger plan when you have a monthly subscription to these guys. They used to give that option with no late fee whatsoever. Whereas these guys had a problem. They could not sustain their business without the late fee. So what was the fundamental difference in the two ways of doing business that allowed this? Do you know?
Monthly subscription. So it's you can.
Yeah, it's $9.99
Yeah.
monthly subscription. Here, you just rent for the movie, like $6, $5 per movie. Right, that was the difference. That was one difference. But what is the business reason why Blockbuster could not succeed without late fee, and these guys had no problem?
No physical store. Physical store.
Physical store, yes, indeed. Physical building needed, right? And these guys had no building at all, no physical store, only this website where you maintain the queue. That was a big thing. It is one of the things that I try to do in my company, is to not have a physical location. Only location I have is this Zoom address or the website. There is no building in Cloud Genius. We don't need it, don't have it. You know why? I learned it from Netflix. No need to have a physical store. No need to have a physical classroom. I used to do a physical classroom 5 years ago. Not anymore. It is not necessary. In fact, what I have heard from people like you who participated in the physical classroom is to stop doing it in the physical classroom because they don't want to go to the college. They find it not only boring, but traffic hurts, and it's a waste of time, 1 hour at least going one direction and then back, another hour lost for no reason. 1 hour, 2 hours lost for no reason and for nobody's benefit. And on top, what happens is, I am able to offer this program on the Zoom conference, and we have people from all over the US, sometimes from other countries also join. And that expands my possibility, easy. It's easy for me to run the program right on a Zoom conference so that it's easy on you. You don't have to go anywhere. You just sit in your home or wherever you are. You participate, you interact just like you do in a physical location. And I don't need to go anywhere. I'm sitting from my home. This is my home office. And that's how I operate. So that's the first thing, no physical location. That means you cut on cost. The second biggest thing that you will think of, which is very different in between Blockbuster and Netflix. And that difference is that Blockbuster will carry Infinity, whatever that thing is, Infinity Avengers. As soon as the DVD comes out, they will have the DVD. Infinity Avengers. Let's see if it's available there, right? Infinity DVD. Infinity Avengers, whatever the name of the movie is. Yeah, the Infinity War. Okay, fine. So the Infinity War, that movie, as soon as the DVD comes out, they will carry it. These guys, they will not carry it. Again, for a very, very simple reason, which is business reason. The difference in these two companies in the behavior is that these guys will like to have the latest, hot off the shelf, hot movies, like really, really, that people want to get, like this movie, for example, or the other movies like, what's the other movie coming up? Deadpool 2. So that's going to come on 18th. So there it is, on the May 18th, you will have it.
and it will eventually come on DVD, but they will have it, they will not. Simple logic behind this is to not carry the hot movies. Not. So what does that mean? It means that what Netflix will actually carry will be considered a long tail collection. I just use an economic word called long tail. If you know what a long tail is, please tell me that you do. If not, here it is. This is what it means. In a long tail market, what you have typically is divide the market into two parts. One of them, the red part here, is the head. These are the hot movies in the market. You have only a few of them, but really, really popular, like the Avengers or Deadpool 2 or whatever comes out. And on the other hand, there is this really, really long tail. There are some movies out there that are available, but rarely people will actually watch it. Occasionally people will. There are exotic movies, like, there is this movie from India that I used to watch, but probably I'm the only one who watches it. This movie. It is also available on Netflix, and it is a 1970s movie that I like, and I watch it occasionally. But that movie is a long tail item. It is not a hot item. It used to be hot in 1970 when I was a kid, but not anymore. So Netflix decides to carry the long tail. It decides to not carry the head. That's one of the reasons why Netflix is able to not charge a late fee, because they are dealing with the long tail. They are skipping these segments. Not there. The hot movies are missing. They let Blockbuster carry them. They're not focusing on that market. That exactly is what they intended to do, is not carry that. Now what happens is when you are not carrying these super hot movies, but instead you're carrying the long tail selection, you're carrying these guys. And so you are able to store these in certain locations. So say, imagine if this is the map of the US, and I have a very bad drawing. Imagine this is the US map, and here is Washington. And in Washington, we have this location, which is the Renton location, is where the Netflix DVD location used to exist, or warehouse. Netflix warehouse was in Renton. Now they don't have it anymore because the DVDs are gone. Nobody who uses DVDs. People don't even know what a DVD is these days, some of them. And so that Renton location used to carry DVDs in the long tail for the entire region. And anybody and everybody who is living in this area will get the DVD from Renton. They will not know whether it is coming from Renton or what, but that's where the DVDs will go back and a new one will come down and things like that. Whereas if you want to store all these millions and millions of movies on the long tail, which is really a long number, it's probably millions, given the fact that, you have not only the Hollywood, which, how many Hollywood movies a year? How many Hollywood movies released in 2017? Let's go figure. And so the answer is something like maybe 100. I don't know the answer. That's why I'm asking. But assume that it is like maybe 1,000 movies. I don't know, but let's see. What's the number? The number of movies released in 2016 is 700. Yeah, so 1,000 was a good guess. So there are thousands of movies available, at least in year 2017, from Hollywood. But Hollywood is small, and I'm saying small without actually making a joke. It is actually very small compared to Bollywood. And Bollywood is, just enormous in terms of number of movies. And you will see how many Bollywood movies released in 2017. So Bollywood, by the way, is the movie industry in India. Here is the number of movies in Bollywood. How many are they made? The list. And it's, I don't see a number, statistics. I'm looking for some statistics, but it's probably 10 times the creation of Hollywood. Most of it is crap. Really, I'm not joking. Most of videos created in the Bollywood, and there are not only Bollywood, there are other places in other countries like Tollywood, Lollywood, and that is not a joke. These are the actual words people use in other countries. But they are movie locations that people will create local movies for their countries. And total number of these movies is enormously big. That's what fits into this long tail. And so if you want to store your movies in a central location like Renton, you can store 1 million movies there. No big deal. Storing 1 million movies in a Blockbuster store, not possible. There is not enough room to place it in every single store, and there are stores everywhere, in every corner of everywhere you will have Blockbuster, and it is physically impossible to store millions of movies in every single store just because it is cost prohibitive. So they could not do it. And what Netflix did was found out that you focus on the long tail selection, this portion, and not here. And thereby they build their business just like that by choosing to not compete directly with Blockbuster in the target market, which is the hot movie market, but instead move a little bit aside and play. And they succeeded. But even then, they had a little bit of trouble. The trouble they had essentially was that they wanted to get rid of the DVD, primarily because, they had some problems. One of the few problems is that, DVDs that you have, if you have a DVD going out to somebody and then it comes back, it may get scratches, it may get lost, and more importantly, pirated. You know what a piracy is of a DVD. If you do not know, you should know about this guy called DVD John. This gentleman is a Norwegian programmer. He created a piece of software called DCSS. And that product, known for DCSS, is a decryption software. It removes copy protection, basically. What it does is, if you have most DVDs and you try to play a DVD on a DVD player that does not have the appropriate region code in which this DVD should be. By the way, for those of you who do not know what a region code is, there are DVD people, or rather DVD standard has divided the world in 6 regions. And if you have a DVD sold in region number 1, which is US, you try to take that DVD and play it in India, it will not play because of copy protection. Similarly, if you have a DVD and you put that in a player and you play and you have a DVD recorder, you try to record it, nothing will actually get recorded. No recording, not possible. Why? Copy protection. The creator of movies or videos or Hollywood, Bollywood, Tollywood, those guys do not want you to be able to copy DVDs just like that. So it doesn't work unless you use this software. Then it works. And this, by the way, is now a part of Linux distribution. So it is available. And this piece of code is part of Linux library, and you can download it from here. And I think the website is something different, but yeah, it's source code. You can see the source code in GitHub and other places. It's built into Linux. So you can technically, I'm not speaking legally, technically copy it using the software. Legally, it is wrong. Legally, copying is absolutely wrong. And so don't copy unless there is a fair use case in which you have to understand what a fair use is. A fair use copy is okay. So you can read the copyright law and figure out what it means and then do appropriately. I'm not an attorney, so I'm not giving you any advice, but there is a way. Here is the way. You can read what US copyright law allows on the fair use doctrine, and based on that, you can understand and do whatever you think is right. And this is the software that broke that copy protection. And so that is turned out to be a problem for Netflix, because Hollywood, which is creating movies, they don't like to give DVDs to Netflix because they know that people are pirating them. And that is what was putting pressure on Netflix, the company. So you don't want people to be pirating your stuff. You are finding that your DVDs sometimes get lost, get scratches, so it's difficult to maintain that business. So you want to actually essentially get rid of the DVD itself. Instead, directly reach the customer on the device that they have in already. Now, those days, like about 10 years ago, 7 to 10 years ago, people did not have these phones in their hands like all over, like we do have these days. They don't have phones. They don't have so many iPads and so many laptops just available everywhere. And people did not have too many big size TVs, and maybe some have, not as popular like these days. The price of a TV has gone down amazingly. So the problem of switching away from this DVD game business over to a streaming business is a big one. So if you now look at the situation where if you have to somehow find a way to get rid of the, let me get to the exact piece of picture I wanted to show you, which is not here. Where is that? Okay. So what I would like to now mention is this idea that if you want to switch away from DVD business over to a situation where people are able to watch a streaming video, couple of things are necessary for that to happen. One of them is that people need to have a TV. That's a given thing, like some kind of a screen to watch it. Some screen. It doesn't have to be TV screen, but some screen. They need some screen. Second thing, they need some internet connection. A strong wideband connection. Internet. I should actually call it wideband, or rather high bandwidth. Wideband is a good way to say that. You need wideband internet available, broadband internet available everywhere, wherever your customers are. And the third thing is that this screen that we are talking about needs to be smart. Smart capability of a TV, as you know, smart TVs are available today, but they did not exist 10 years ago. And there were some, but not too many. So the way to make a TV smart was typically by adding a box to the TV. So what I'm talking about, this box, is basically it's a device that I will call a client device that interfaces with a server device or service device on the cloud side or the back end. Maybe it's the back end in a data center. It may not be cloud, it may be a data center, depending on what Netflix company decides. This client device will interface with the service and get the movies streamed, and then it will show that video. That device is necessary because the TVs are not smart to begin with. You have some wideband growth, so this wideband is growing. TV screens are becoming bigger and bigger, and availability of a box is also slowly growing. The market is evolving, at least 10 years ago. So now at that time, you had Netflix to make that decision. On the client end, what should be the experience to the end user? Like, what should they receive? What should they have? Should Netflix create their own device? Should there be a Netflix box? Like there is these things called, you may have heard of a thing called Roku box, or Apple TV, or Amazon Fire TV. These are boxes that are considered to be smart, and they are connected to a smart screen or some kind of a dumb screen sometimes, are able to produce the experience that people will expect. But have you heard of a Netflix box? I haven't. It did not exist. It never came through. But the question is, should Netflix create their own device or partner with a device manufacturer? Or, if we decide to partner with device manufacturers, like for example, if you go to this website and say Netflix devices, and you will find a long list. And so here is a list of devices that Netflix supports. It's a fairly long list these days. You have smart TVs, which are from these companies. You have streaming media players, Apple TV, Fire TV, Shield, and Roku, and Nexus, and Chromecast. You have game consoles, Xbox, Nintendo, PS3, PS4, Wii, Wii U, Wii Connect, God knows how many of these guys. And then there are set-top boxes from every cable company. And there are Blu-ray players, and there are smartphone tablets, and there are PC and laptops. Bunch of devices. But that is a relatively recent phenomenon. Initially, we did not have that many choices. In fact, Netflix didn't even run on Android phones. All it did was just Apple iOS. Because the Hollywood industry did not feel quite comfortable with Android, because it being Linux. And the fact that you have Linux, meaning you can control what goes on and you can decide what to do with it. So they feared piracy on Android. So they did not actually create an Android app until late in the game. The questions I have for you is, how would you decide what should be the answers to these questions on the client end? And similarly, on the cloud end, who will manage the streaming backend? Who will maintain and upkeep the data center? And how to deal with data center growth? Those are the questions I have for you. Meaning, if you have let's look at the client end first. The client situation. When you have people, most of them have some kind of a screen, but the screen is not smart. So you have to connect some kind of a device to it. The first question is, should we have a Netflix device or should we not have a Netflix device? And then comes the second question. If you decide to have this device, which is why or why not? If you have no Netflix device, again, why and why not? And if so, which device do we partner with? We have these guys like Microsoft, Apple, Sony, Nintendo, and others. Which companies do we partner with? And then put our Netflix application experience right here onto these devices. Basically the Netflix app. So the question I have for you is, how would you make this decision, whether we create a Netflix device or not? What should you consider? How would you go about thinking whether to create this or not?
Do the survey of marketing, like how the people are, what they are using more, which is benefit for company?
Yes. So people don't have a clue about Netflix device, right? There is no such thing. And so how do you survey a situation like that? When people don't even know whether Netflix device, and what do you do with it again? We already have these guys like Apple. I have a Nintendo. I have a Sony. Somebody will say, I have an Apple TV. Somebody will say, I have a laptop. I use it on my laptop. Somebody will say, I have a Sony PlayStation. So what do you do with Netflix? How does Netflix come into play? How do you actually go about thinking and maybe deciding whether to have a Netflix box or not? So survey will typically not give you the answer because people don't know, right? So surveying is not going to lead an answer. So what you have to actually do is think like the end user thinks. And an end user is typically this person who is watching the big screen is a couch potato. The guy doesn't even want to move. Forget about moving his fingers on the remote. That even they don't want to do that. Unless, the behavior of this person who is on the couch is typically divided between male and female. females, they typically see what's on TV. Whereas male, the behavior is what else is on TV. You see what I'm saying? These people typically flip the channel to find out what else is on TV, versus females are typically watching the TV. So that behavior, and these guys mostly, both males and females, they just sit and watch and just be inactive. They don't even have the inclination to get up and change the cable that connects to the TV between this device or that device. They are so lazy. You know that for a fact, because that's how people are, lazy. And so it is hard for people to get up and connect another device when they already, and it's behind the TV, and who's going to go to the cabling and all that. It's just a nightmare, right? For this person who is basically a couch potato, you expect them to get up and do what again? That is the hard challenge, right? That's one of the reasons why Netflix decided to not have a box, because we know that people are lazy. They will not get up and move a cable behind the TV. Are you kidding me? No, not doing it. So what do you do in that case? And another challenge is most of these televisions have 3 or 4 HDMI ports. And so they are probably already occupied by these guys, or some Comcast box or some DVR or something else is there, and it's taken the place. The HDMI ports are occupied. So you now have one more. Where will I fit in? Even if I'm not lazy, if I get up, I still have to remove a cable and then put another cable. And then what if I want to watch that one again? And that's a problem right there. That's one of the reasons why Netflix decided to not have a Netflix device. And now you have to choose between not having a device, so that you go and then contact these companies. Microsoft, basically Xbox team, asking them, hey, can you please include our application that we will create for you? So you still have to write code for the client, which goes inside into the Xbox Live service and becomes available on the Xbox. And do the same thing with Apple, do the same thing with Sony PlayStation, do the same thing with Nintendo, and then expand it to other partners slowly. And eventually you get to this point where you have lots and lots of devices. And you now have a large collection of people, companies, partners who you work with that provide the experience that you want your people to have using the client that they already own. It's already there in their homes. All you need to do is inject your application into the PlayStation and then let this lazy person play the PlayStation. That's it. You get Netflix. That's the design that they had in mind when they chose to not create a client device. We'll talk more in detail and we'll slowly go into depth. We'll go to the level of depth until you feel nauseating. And when you do, you should tell me to stop going deeper. So just bear with me. I will go deeper in each and every of these aspects to help you understand the depth which it takes for a company like Netflix to actually implement and play out the experience that you are very familiar with in running the Netflix scenario on your setups, on your computers or whatever you have. So that's the scenario you will see going deeper and deeper slowly. Now on the cloud end, on the back end, if you will, like here, you have this client device where the user is using some device of some sort, like PlayStation, for example, connecting to the backside where the movie comes from. And the streaming is happening. So on the back end, you need to have some kind of a data center or some machine somewhere sitting, managing the streaming experience. Now that you want to build it yourself, or you want to rent it from a cloud company, or build your own. So it's essentially a build versus rent decision. Build or rent. Should you build your own data center, or should you rent a data center? What's the right action? this or that. And so how do you go about thinking like this when you have such a question in front of you? Should I build a data center? It's a big company. We have money. Should you spend $10 million on a data center or not?
Depends, usually.
So when do you actually build a data center? In which case would you like to have your own data center?
Well, I would say now would be a good time to have if it's part of your core business.
Core business. You're hitting a good point. Okay. Let's expand on that idea of core business. So the core business, I would actually say that the core business focuses on something that I would like to call core competence. And so if your core competence is something, you should do it yourself, right? So if you have, let's pick this example. By the way, this word core competence comes from one of my professors. His name is C.K. Prahalad. You may have seen a video lecture on this. This dude, he's the reason why I came to the US. He was a professor at the University of Michigan, where I studied my MBA about 17 years ago, something like that. He is gone. He's not there anymore, but he was a famous professor who coined the word core competence. Core competence. And of the corporation is a book written by him, along with Gary Hamel and C.K. Prahalad. These two guys wrote that book, which basically describes the concept that I'm going to describe to you right now. That concept is, imagine if you are a brain surgeon and it is Saturday, sunny, afternoon, after lunch. You are free. You have nothing to do. That's the scenario. You have a lawn. The lawn is growing. You have a lawn mower. The question I have is, this is you. Should you mow the lawn? You also have a neighbor. The neighbor has a teenager who is also free, sitting around idling in the sun. Now, should you mow the lawn? What do you think? It's a trick question.
Yes. Yeah.
It is a trick question.
I was going to say you should hire a landscaper.
Yeah. Yeah, but the lawn is growing. It's not that big a deal. It's just a question of mowing the lawn. So the lawn has grown and you just have to cut it. That's all it takes. Right. You have a lawnmower. You have a teenager right next door to you. They know you. You know the teenager. You know, he's physically fit. He's capable. And he's just sitting out in the sun. You're also sitting out in the sun. It is nice and sunny. And you had your lunch and everything is okay. And you're just sitting. You're free. The question is, you're a brain surgeon, right? So should you mow the lawn yourself or not? What do you think is a rational action? It's an economic trick question. It's an economics question. It is a trick question. I just tell you.
Pay the boy and get the lawn mowed.
Why?
Because he's learning and you pay less.
And your time is worth more.
Keeping the kid busy.
Yes. But I don't agree with that answer. The reason is, let me give you another example before I answer this. So let me give you another example. Of course, these are subjective decisions, but I have my perspective. I'm just giving you my perspective. The other way to think about is this guy. You know him. His name is Bill Gates. And he is walking on evening and in his own home, right? And here is a big house in the Lake Washington. And so here is his home, from here to here all the way. And so he's walking here and he finds $100 bill on the ground, his own ground. Now, should he, as he walks and takes a stroll to this point where he wants to go and then come back, he finds $100 bill and in his own home. Now, my question is, should he bend down and grab it or not? Does he care? Should he? It's an economic question.
Yes.
Right?
Yeah.
He should bend down and grab the $100 bill. But he's a multi-billionaire. Should he even bother bending down for $100? How about $10 bill? Should he bend down and grab it? Again, you say yes.
Yeah.
Okay. What about $1 bill? Should he bend down and grab it?
Yes.
Okay. What about 1 cent? Should he bend down and grab it?
I think so. Yeah. It's a money.
Yes. That's exactly what I'm saying, right? It is money. And he is like on a Saturday morning strolling around in his home and he finds a penny. He should bend down and pick it up. It is rational decision, right? It is very rational. It is money. You found money. It is your home. You pick it up. Rational. Nothing wrong with it, even though you are multi-billionaire, right? Now go back here. On a sunny Saturday afternoon, you are free. So if you don't mow the lawn, is very, very similar to you not picking up the $100 bill. You should not be paying the teenager. Instead, you should mow the lawn yourself. Yes. And save the money and not pay the teenager, because that is a rational economic decision, just like this one is. Otherwise, you're throwing away the money. You're giving it to the teenager and still doing nothing. And you just lost $30, whatever you gave to the teenager, right? You can pay $30 to the teenager and you're a brain surgeon, you have enough money. And so you just pay $30 and so he mows it and you're still doing nothing, and maybe you want to enjoy the sun, and that's okay. But it's kind of sort of similar, right? If you're paying the teenager money and you have nothing else to do, and you, by the way, need some exercise, and so it might actually make sense to mow the lawn yourself. However, now I'll change the picture. What I'll do is I'll change. So I'll say, now it is not Sunday, but Monday. And you have work to do. You are supposed to be doing brain surgery in the hospital. That's what you're supposed to be doing. Now you tell me the same situation. You have lawn growing, it is Monday afternoon, and you are at work. Should you go back home and mow the lawn?
No.
No. It's a very clear no answer, right? No doubt about it. No, you should not mow the lawn. Instead, you should just pay $30 to the teenager and let them do it. That is a rational answer. Because you should do what you do, brain surgery. It is your core competence. So now, here, core competence. Netflix, the company. What is their core competence? Should they be setting up a data center? Should they be worrying about cooling their computer? Should they be worrying about wiring these cables? Should they be worrying about hard disks breaking down? Should they be worrying about memory going bad? Should they worry about updates to OS? Should they be doing these things? What is their core competence?
Streaming.
Yes. So they should not be doing this, right? So you outsource it to people who know how to do this thing, how to manage data centers. And you know who these people are. They are your usual suspects, the cloud companies that you know of, the Amazon Web Services, the Azure company, or the Google company. These guys know how to run data centers. That is their core competence. Right? That's how they're doing it. They're doing it. They know, because that is how their bread and butter is. These are the people that they know how to manage a data center. And in fact, there are many examples on cases and studies you can see where the best people who know how to manage a large scale data center are the people that do it for a living. These guys are known to do that for a living. So that is one of the reasons why Netflix decided to not do what is not their core competence, to cool the machines down. No, not doing it. That's one of the ways that we should think. The other way to think about is also a very important one, which is that I want to focus myself on not building, but renting. So I don't have to deal with the actual issues of cooling these machines and all that growth that I need to handle. It's very difficult to grow a data center because of a simple reason. Here is how the problem lies. Here is the problem lies. Imagine now this situation. You have a time on this axis, and on this axis we'll have some money on one axis. So let's see. Now you want to set up a data center. Okay, fine. Spend $10 million upfront. 10 million gone. You now have a data center. It has this much capacity. This is your capacity. And it is there for the future. You have it, you spent it, it's there. Now, you have to make money, you have to make profit. And this customers that will start coming and trickling in, you will see that these customers will eventually, you already spent $10 million. So you're down negative 10 million already. You're already negative. Now on this situation, you will eventually see that some customers will come and they will start slowly providing you money. This is your revenue. And this is your cost, at least minimum cost. You've already paid up front. Now the revenue is slowly growing, and sometimes it goes down, sometimes it goes up. You have no idea whether the money is positive. At some point, you have to cross this line like that to break even. But it is so hard to predict when will you actually break even. It's kind of impossible. You have no idea whether customers will come or not. Nobody knows when they set up a business whether customers will actually come. There is no way. I have set up my own company 5 years ago, and yes, I started with 2 customers. 2. Yes, it is difficult. You have no idea whether customers will actually come or not. So if you spend upfront money like this, like an idiot, you will be down $10 million already. Instead, there is a better way. The better way is like this: that you don't spend $10 million upfront. In fact, you spend nothing upfront. So what do? You have to find out that you have to spend. So you spend as you go and not spend upfront. So the cloud gives you the ability to spend as you go. So these customers are coming in slowly, And so you need to make sure that you spend money. So you are going to spend money on some equipment, and this is going to be a rental equipment. And so the rental, you pay as you go. So you basically are renting somebody's cloud. You pay them for 2 machines, 3 machines, not too many, not hundreds, not thousands, but just a few, just to get by, get some services running, get your customers happy, and they will come. They will eventually find that these customers will eventually grow. And at some point, you have to make sure that your infrastructure that you have is capable of still handling the need of the customer. So you have to keep growing your infrastructure as the customer demand grows. And at some point, you will find that the customer demand might shrink. So you have to then shrink your customer demand, or rather, shrink your number of machines you carry. And sometimes you will see that the customer demand suddenly shoots up. And then what do? You auto scale your cloud. And then the customer demand kind of stables out. And then you stabilize your cloud. But at almost all these points, you will notice that you know that you are making a profit. Except not here, which is fine. This is not profitable, which is okay. But at least you know very quickly here onwards that you are kind of sort of already have a clear idea whether you are making money or not. Whereas in this example, you have no idea when will you make money. This break-even point comes at some point in time, you have no idea. In here, you have the idea very, very quickly. You already know because your money is spent as it goes, as the customer demand grows, not all of it upfront. That is the reason why Netflix decided to build their entire business on Amazon cloud, or rather the cloud, some cloud. At that time, it was just Amazon, most of it. Almost, they were the first movers and they had a big cloud at that time. So Netflix said cloud, meaning Amazon cloud. That was the only game in town that time. Almost. There were some people, but not as big as Amazon. Even today, nobody is as big as Amazon in terms of sheer size. So although other people are growing, Microsoft is growing, Google is growing, but they're not as big as Amazon. Amazon is like 35%. There's some picture that you may see here somewhere as to who's bigger than. And so you can find somewhere here. I'll pull it up and find out where it is. Somewhere in here, you should be able to find a picture that tells us relative comparisons of these cloud companies. Where is that picture? Yeah, no. I'll find a link. It's there somewhere on this website. You have to click through and find it. I'm making it searchable. I just added a feature that makes this entire site searchable, which is easy to find. So we'll get to that feature later on. But right now, back here, the core idea is to be able to quickly predict break-even point. As quickly as you can do, the more reliably you can run your company. Now, you might be shocked to see the amount of money I spend in Google Cloud for my company, and get ready for the shock. Can you estimate how much do I spend on the cloud? How about that? Give me an estimate. What do you think?
A few dollars a month.
You are bingo on the spot, by the way. You are absolutely on the spot. That's exactly how much I spend, give or take $1. But let's see. So here is, I'm going to look at my bill, live bill from Google Cloud, and you will see it. So here is the bill and billing, and you will see what I spent last month. And here are the transactions, and the money spent is how much it is. There's a transaction report. Yeah. So starting balance this, and the ending balance was 171. So that's the amount of money I spent. And the budgets and alerting. So my budget limit is 150. I sometimes exceed the budget, but that's what I spend typically on an average basis. And this runs everything that I have in the Google Cloud. I still have a couple more dollars here and there for DigitalOcean and Amazon and Vultr and Scaleway and a bunch of other small little players. I spend $1 or $2 here and there, but that's the kind of expenditure. And yes, I'm running my company because of this idea right here. Because I don't have a data center, because I don't need to. Actually, I do have a data center in my home, in my garage. There is a private cloud here, but it is what I call sunk cost. I already spent that money because I was stupid. I was behaving like this. And I spent quite a bit of money. It's not that millions of dollars, but thousands of dollars I spent, and it's sitting there in my garage. And it is a bunch of machines that are my private cloud, and I use it. But yeah, I just treat it like my play money, and it's gone. So that is my sunk cost. So I ignore it, which is what economics will tell you, to ignore sunk cost as you make decisions. So the core idea that I want to drive to you is to not build a data center unless it is your core competence, which is like you are Amazon or you are Google or you are Microsoft, or more recently, Dropbox. So Dropbox saved whatever, just read that, saved almost $75 million over 2 years by building its own technology infrastructure. They built their own data center, and they stopped using cloud this year, February 2018. The recent news last month, a couple months ago. This Dropbox company that you probably already use or probably already aware of is a company that used to be on the Amazon cloud from its day one. But late last year, they decided to go away from Amazon cloud. So it's a different kind of migration. It is the reverse migration away from cloud, because at this point in time in Dropbox life cycle for their company, it makes sense and sense for them to not use the cloud, because cloud at some point becomes expensive. And that is the reason why companies like Boeing will have a strategy in which you will do both. You will have a private cloud and you will use public cloud, and you will do both and find out which is more optimal. And for a company like Boeing, that makes total sense. That is exactly how you should do. For a company like Dropbox, begin small, begin with the cloud, and when you grow and become big, you go do it yourself, because now you know how to do it yourself. Then you walk away from the cloud and do it yourself. That's what they did right here this year, earlier this year. That's the news. Now, a company of my size, I don't even want to set up a data center. I don't even know how to cool down my CPU. Maybe I do, but I'm not the best in doing that. So I don't bother. I just use rented computers, and that's the best way to use. That's the best way to, my core competence is to talk. That's what I do all day. I talk. And so that is my core competence. Maybe I demonstrate. That is also my core competence. I show live. I crack bad jokes. That is my core competence. So bottom line is, core competence is the way you should think about whether you should have a data center for yourself or not. That's a thing to remember. Now back here, on to our Netflix discussion, which is, where did it go? Yeah, here. The bottom line is they decided to have their own, where is that? I'm missing another picture. Hold on. Here. Next. There is another picture. I was trying to find it and it's there somewhere. Maybe next. Yeah, maybe this one will have the pictures that I was looking for. This slides. Come on. Pictures, please. No, wrong one. Wrong one. Well, I don't have the pictures, but I'll continue our discussion. So what I want to do next is to understand how these components get built from a usage perspective. We'll first focus on the client side and then focus on the back end, the cloud side, as to what does it take to build out a complete solution set. So now let us focus first on the client side, which is basically a device in your hand, in my hand. In my hand right now, I have this Macintosh. If you look at the display properties of, the display properties of this Macintosh, you will see that I have a resolution capability. The defaults selection shows me the resolution is, and look below the laptop picture here. Look below in this segment as I hover. So you see 1440 by 900, that's the resolution. If I hover here, the resolution goes to 1680 by 1050, and like that. Here, 1920 by 1200, and all the way to the other end is 1024 by 640. And I am not going to change the resolution right now because it will distort the experience that you are getting through my Zoom conference. So I'm not changing it, but this is the thing that I want to discuss, is display resolution is one of the key factors that decides the client experience. And if you look at this picture, you will find what I'm talking about, and you will understand what I'm really talking about, is the enormous complexity when it comes to dealing with display resolution standards. Let's go look at some of them here. If you look at this point in my mouse, where my mouse is, and look at this item called VGA, that item sticks at that point here. And if you now, let me just annotate that. I think that's easier. So I'm going to annotate here. This point here is your VGA, which is the US standard NTSC signal. According to NTSC signal, a display screen should be this high and this wide, and the entire segment should fit into this segment. That's how is a old style television was expected to, for performing NTSC. This standard was expected. In India and Japan and other countries, I think not in Japan, but I think in India, the standard is PAL. That's the standard available, or rather used, this PAL standard. In other countries like Japan, I think they use, they don't have it in this picture, but yeah, one of these dots, meaning the dots are close to this point. The diagonal is small. The resolutions are different in different countries slightly. If I erase all these and then look at a standard laptop that most of us have, most entry-level laptops, cheap laptops, they're typically these days here, either here or here. So it is either WXGA or slightly bigger than that. That's the resolution that you will see. Most commonly used cheap laptops are here, these names. So they belong in this spot here somewhere. So the resolution is, of course, different for different screen sizes or different screen shapes provided by the manufacturer. Now, if you go slightly higher, you will find slightly more expensive laptops will have a different resolution pattern. Like I just showed you, my laptop was showing you this resolution, but actually the resolution is this resolution. It is shrunk to this point to make it easy for you to look at in a Zoom conference. My actual resolution that I use is this, but I shrink it down to this so that you can see and don't have to squint your eyes and you don't have to zoom your screens and things of that nature. So I shrink it to that point, to the 1440-900 point, to make it easy on you. But resolution is this, and this is a MacBook Pro. Now, if you keep going, you will find eventually, right here, this spot is a HD spot. This is your standard HD TV. In most homes, you will find this television 2 years ago. Today, you will find most homes have evolved, and people are not interested in HD TVs anymore, but they are getting what is called a 4K. And 4K TVs are getting popular. And that is another challenge for companies like Netflix, because now the resolution point is not this, but this, which means actually at the end of this is where the resolution is going to be, meaning the whole screen width all the way, height and width all the way, is the 4K resolution. Now, what I'm using on that computer over there is one step even beyond this. So if you now look at what I'm talking about, is this idea, which is 5K. You may have heard of it. 5K Retina is the iMac resolution. So let me erase these guys. Annotation, clear, all. And this machine is what I'm talking about right there. Now here it comes with a resolution that goes beyond what can be demonstrated in this particular picture, because this picture goes beyond 4K and it is actually 5K. So if you now, okay, hold on, let me shrink it. Let me adjust the screen again. Yeah, there we go. So this, the endpoint at the bottom is 4K, and 5K is even bigger than that. So it will not fit this screen, this image at all. And that is the resolution available on the 27 inches iMac, which is gigantic, huge. That is another challenge. So from a video rendering standpoint, Netflix as a company that provides you user experience of showing you the live video, streaming video from wherever they are onto a device that you carry at a given point in time. And sometimes you will carry an iPhone, sometimes you'll carry an Android, sometimes you'll have a laptop and a desktop, sometimes you go back in your living room and have a big gigantic 4K, 5K TV. And you expect crazy things to happen. For example, I will have my Netflix running on big screen TV, and I'll watch a movie halfway through into it, and then I will suddenly pause, because now I will become a passenger in a car driven by my son, and he drives, and I will go sit in the back seat and watch the remainder of the movie on my iPhone. That is what I expect. And so that becomes a scenario which is very difficult for Netflix to implement. Now you were watching a 5K Retina in your living room, and now you suddenly switch to what again? iPhone, small screen, and you want to watch the same exact movie. That's a problem. Sometimes people in some cases you will have cross company platforms used. I will watch a movie on PlayStation, and then I will switch to a Windows laptop, and then I'll switch to an Android phone as I am driven around, and as a passenger sitting in the backseat of a car. I'm still watching the same movie that I want to watch, but I'm changing my devices on the fly whenever I feel like. That's the expectation people have. That's the design of experience Netflix wants to deliver on. That is one of the things that Netflix has to account for in its delivery experience, is to account for the varying levels, or rather the plethora of various display resolutions. That's one big challenge right there, right here, display resolutions. So if you now go back to our screen and describe the challenges that Netflix needs to account for, one of them was display resolution. You saw already the nightmare of possibilities in that leads to a test matrix of a very big size. You have to test every single scenario to meet the requirements of expectations of people using variety of display resolutions. That's a test matrix already become large to begin with. Now, on top of this, you have additional complexity. That complexity is that you have to adjust. Let's focus on these things. At the bare minimum, you have 1024 by 768 is the minimum resolution most people carry these days, and on the higher end you have 5K. Now, if you look at an ordinary movie coming from Hollywood, these guys will produce a movie and they will make that movie available on a gigantic screen, and that screen is typically the IMAX screen, the maximum size you can get in the US, that screen. Now, if you compare this 5K resolution, I think it is Let's see what the resolution of 5K is. 5K resolution is what? It is 2880p. So the number I want you to remember is this 2880p, as opposed to HDTV is 1080p. This P stands for progressive and is the number of lines you will see on a, or rather I should draw it properly, the number of lines you will see in a screen being rendered one after the other, like that. And if you count the lines, they will be 1080 lines. That's where this number P, progressive lines, comes from for HD. So on a 5K screen, it is 2880p. So if you calculate this same thing for the resolution of an IMAX screen, which is what Hollywood typically produces for IMAX screen at a movie theater, is what they want people to go and spend $20 on a ticket and watch the big screen movie there, is what people, rather Hollywood, wants. And so they produce this kind of a gigantic resolution. I think this resolution, the last time I did my calculations by measuring the screen and actually estimating how many vertical or horizontal lines that you will have, it turns out that it is 18,000p. That many lines in a screen. Let's actually cross-check this IMAX resolution. Let's see what comes up with. So the idea here is the equivalent of 18,000 lines of digital resolution. That's the answer. So more like 12,000 in reality. So that's the resolution of an IMAX theater. Let's call it 18,000p, for example. So that's what I'm going to call it. So that's the video file that Hollywood typically prepares when they are shooting a movie and then sending it to the theater. Now, Hollywood also dictates a couple of things. For example, they will make sure that Netflix does not receive Avengers Infinity War right away. In fact, they have a kind of a schedule as to when they will actually release a movie in various channels. The first thing they will do is a premiere. And this premiere show is exclusive, so only limited audience. Then comes the actual release, a release to the movie theater. At some point in time after the fact, they will actually do a DVD release or a Blu-ray release or other forms of recorded media and make that available for purchase. At some point in future, you will see that Netflix will receive it. And before this happens, I have recently noticed that people like iTunes will receive it before, and they will sell the movie. Not rent, sell. Now the rental movie will typically show up sometime after that. Rent the movie. For any movie that releases, premiere, theater, DVD, Blu-ray, eventually iTunes will sell, and then iTunes will rent. And at the same time, or maybe a little bit after that, it becomes available on Netflix. That's when it becomes technically a part of the long tail. And so you can then have it Netflix, and now you let people watch it based on your subscription model. The same conceptual thing you will see is what singers do. A singer like Adele, she decides that her album, the Hello single, would not go out to iTunes. iTunes did not have Hello, only for purchase, not for streaming until late in the game. So streaming radio like iHeartRadio or Pandora or other people like who are Netflix analogous equivalents for music, these producers like Adele will decide that this song will be available only purchase, and later on will be available in streaming solutions. So streaming solutions such as Apple Music. So you pay a flat $5 per month, $10 per month, whatever that price is. And then you get to listen to any of these songs available in streaming mode. And that is conceptually similar to the Netflix idea. So they are the last ones to actually receive a video. But when they do, they are actually getting this. Now you have to adjust that resolution over to all these choices available out here. Not here. The picture I showed you, the same picture. All these plethora of test matrix that I mentioned. So you have to somehow make sure that this video that is available, produced by Hollywood, is playable on the entire selection of test devices that you support. So you have Netflix devices. Where is that? I think I closed Netflix devices. Netflix.com/devices. Maybe not. Okay, Netflix devices. As you see, the list of devices is a fairly long list, and now that Netflix supports all these devices, which are here. No, here, devices.netflix.com. So that's the site. So you see these variety of devices. Each one of them will have a different resolution. That's what I will like you to understand is the work item that the Netflix company has to do. There's a to-do list, and the to-do list essentially requires somebody or some computer to convert this thing into all these various solutions, various resolutions that Netflix wants to support. And these supported resolutions are a large number of them. So that's a work item for Netflix. And that needs to happen before the client can actually play this new movie, say, whatever, Infinity Avengers. So that movie has to be able to render on a small screen device. It has to be converted, or I would say, transcoded. And this is a new word for some of you, so I'll explain what that means. What happens is when you have a movie showing up in a theater, it is typically sent raw, in full glory, multi-channel sound. That's how you receive a movie in a theater. It is digital, but it is raw. And so it is not encoded. But if you now recall, you may have heard of these things. And tell me if you haven't. I think you know this. You know this also. You may have heard of this thing. You may have also heard of this thing. You have also heard of this thing. Maybe not. So what am I describing right now are video and audio codecs. These are generally used by the standard Motion Picture Experts Group. These are used by Microsoft. Windows has it. The Windows Media Audio and Windows Media Video are the codecs. These are used by Apple devices. These are open source. And there are a ton of them in open source. These are just two examples I just picked. There are more. Like you may have heard of this thing called FLAC. You may have heard of this thing called Matroska, or other formats from Google, VPC, from Apple, again, new one, the new codec, which is not open source. but it is better than these guys and these guys. And I don't remember the name of that codec, but it's a recent iOS 11 codec, one of the latest codecs available here. I don't know which version of iOS does support it, but there is a codec. They keep innovating that on Google and Apple. Both are innovating VPC 9 codec from Google. And so does Apple, has a new codec, and so does Microsoft. And there are these codecs available that basically refines the experience of video and audio on these smaller devices. And as a fact of the word, codec basically means it is a coder and a decoder together. That's what codec means. So you're coding something in which is not raw anymore, because you coded it. And then when you want to play, you want to decode it. So that is coded format, and then you decode it, and then you play. So this decoding happens already on the devices that you and I carry, like on our iPhone, Android, PCs, laptops, desktops, TVs, all those devices. They decode all the time. In fact, any media that you typically play is encoded, and so it is decoded on the fly as you play it. So that is decoding. But then when you get a raw file from somewhere, like Hollywood, for example, or your own creation, like you create House of Cards, as the Netflix company did. So you have a camera producing a video, you need to store it. That is a raw video to begin with. And that raw video is kind of impossible to transport on the internet. Practically speaking, you cannot. In real time, you cannot. You can transmit it, but it will be slow. So you want to send a live video, you cannot transmit raw. You have to encode. And by encoding, what it does is a big fat file gets shrunk into a thin stream, so it can actually travel the internet. And then you can expand and then expand and make it to go appropriately to the size needed at the target end and the client end. And that piece is the decoding aspect. But this decoding happens for both audio and video. You have to begin with a raw file that you take and you encode it, and you then stream it, and then you decode at the client end. That's a typical flow of media, or rather audio video, that reaches the end customer. So if you now take all these things like we mentioned, by the way, I'm just checking if you know these things. I'm pretty sure you do. So I just want to make sure that you already understand what I'm talking about by asking a yes or no question. At least in this square box, this rectangle box, please tell me that you know what I'm talking about. Yes? No?
Yeah.
Okay, good. Good. So others, the open source you can ignore. They're not so popular, but I don't expect you to know these. But these are the other ones, the industry ones, the Apple and Windows, are very popular. So you already understand what I'm talking about. That's good. So now let us see how will Netflix actually do the work. Like, what do they do in the company, right? I mean, what do they do versus what their machines do? We have to really distinguish between the two. And so let's go focus on what do the machines really do for Netflix in order for the user to get a satisfactory playback experience. And the client has to decode and playback, and the playback has to have certain characteristics. And one of the characteristics will be that it will not stutter, it will be smooth, the audio should be good, it should be slick, and as soon as you play the play button, it responds. All those characteristics that you would expect from a regular local DVD playback is what you expect from Netflix on the streaming device. That is a critical thing to remember as you go and understand what's going on under the hood. So now if you take a look at the picture that I had here and understand how does this apply to a company like Netflix as to making sure that they are able to actually produce the kind of experience that people will expect from the company. For that purpose, we will use this as a reference picture. In this picture, what you will find is that it has several references to Amazon specific technology. And that is a good thing and a bad thing. Good in that it helps Amazon in selling their products to you. So everything that you here see is basically Amazon specific thing. Every component that you see here is how Amazon wants you to believe that is the only way to do things, because that's how they will make money. They want you to believe that this is the only way to do it. And therefore they will use these words very, very specifically, saying that you have to use an Amazon XQS to accomplish that. But let me tell you, that is not the case. In fact, let me tell you that you don't have to use any of these Amazon products. There's nothing wrong with using their products, but I'm just telling you that you don't have to. You can pick and choose components that you think are right for your case, for your design, for your application, from any cloud, from outside, or even your internal cloud if you have one, or build it yourself if you don't have one. So any technology will work as long as it solves the customer problem. But now, from that perspective, take this picture. By the way, it's a nicely drawn picture, and I'll give you a link, and I'll give you the PDF. You might be able to find it on the Amazon Architecture website already. If that happens, just paste a link on Slack chat so everybody else also gets it. Nothing in here is specific to Amazon Cloud. Just take that with a pinch of salt. So remove the Amazon pictures or other Amazon references and understand it from the concept perspective as to what are we really trying to accomplish. So now let us imagine the role of a person or maybe a robot, one of those two, right? You know, most of it is robots these days. So things are done by robots. So let's imagine this person is a robot inside Netflix, is doing some work. And what is that work? The work we just discussed, which is take the movie from Hollywood, the raw video that you receive that. And that robot or a person, you can think of it as a physical person like a dude or a lady or a machine, any of those, any robot. So some person, some representation of the Netflix company. Let's think of it as a Netflix employee bot. Doesn't have to be a person, just that's what I'm saying. Now that entity will take that raw video for Avengers, for example, and Avengers will come out on some date in the future. Let's say July 15th or 4th of July. Let's say 4th of July is when Hollywood decides that Avengers Infinity War will become available on Netflix on that day. They decided that. Who decides? The creator decides. Netflix doesn't decide that. The creator, who is the, Marvel, basically Marvel decides that the release date for Infinity War DVD will be July 4th or maybe July 3rd, and Netflix July 4th. That's how they decide. So that date is relevant. So you just put that up on the top. They give you raw video file right now. Here, this is April or May. I give you the video file right here, right now. So take it. Just make sure that you don't release it, because the date given to you is not today, but July 4th. So that's the day when Netflix should have it publicly available. I'm giving you that file right now. Please take it, store it, but don't release it. I hope you understand why they would do that. Is to give Netflix lead time so they can prepare itself. Netflix can prepare themselves to get the result to the end user on the target date. So we have May 2nd or 3rd, whatever that date is today, 3rd, 2nd. So May 2nd, and the movie becomes available to the Netflix bot. Now, what do we do? So we take that movie and then upload it. Upload it where? To some endpoint, some named location, pretty much similar to what you would see when I go and upload a video to YouTube. So there is this URL endpoint which I'm visiting right now, and I will go and upload some video if I like, right there, upload. That's conceptually the kind of action that you will see, that I'm going to upload a movie video and I just drag and upload it. That's how you do. That's the exact scenario I'm talking about here. Now, again, this can be automated. So this is a bot doing it, and it is uploading some raw video of Infinity War into the system. It is going inside. And that the first thing it deals with is a load balancer. Now they are calling it to be Elastic Load Balancer, meaning it is an Amazon product. But let me tell you that we have seen other load balancers already. I showed you the Traffic Load Balancer last time, open source traffic. You saw that already. So there are many such open source solutions. This doesn't have to be the case. Although this picture shows you Amazon's Elastic Load Balancer, which is fine. Nothing wrong with it. Just saying that it can be any load balancer. So the first thing you will see is the load balancer, and then it will assign that work or the upload action, uploading this Infinity Wars movie into some upload servers. These upload servers are responsible to receive the video and what? And dump it right here in the bucket. This is a bucket, S3. Again, it doesn't have to be Amazon's S3 bucket. It can be any cloud storage or any storage for that matter. Doesn't even have to be cloud, any storage, but Amazon, they use Amazon cloud, so fine. So you just, upload servers will primarily do a couple of things. One of them is dump it here and then assign an action in a to-do list. The to-do list action is to transcode. Transcode. Transcode what? The same thing we discussed before. A ton of different variations of codecs, audio codec, video codec, resolution, this and that, goes on and on. So big, gigantic test matrix. That's what you need to transcode. That's the to-do list. This to-do list applies to every movie. This is just one of the movies. So you have to transcode and you have to dump it into the bucket. That's what this upload collection of servers will do. However, you will find that this Infinity Wars is not the only movie that is coming in. There may be other movies from other locations coming into the system, into the Netflix system, and this robot may be uploading that. And there will be maybe many more such robots here. More of these guys, more people, more robots uploading new movies of different types from different countries, different locations into the system. So the load balancer will automatically scale the number of upload servers available according to how many movies are coming in, how much work item is there incoming. So there are lots of people sending movies into the system. This EC2 Cloud will grow the number of upload servers like that. And this yellow segment that I have here drawn is basically an indication of the fact that it is a auto scaling group. And having said, I would like to show you a live example of an auto scaling group. We can do that exercise after we discuss this. So you will really understand how does auto scaling work based on load coming into the system. And you will see this thing live. I'll run it for you so you'll understand very clearly. I think you have seen some manual scaling. When I was doing it the last time, I was manually scaling some containers to grow to number 23, number 45, whatever random number I chose. And it grew, the number of containers grew. And I was able to shrink it down manually. I was able to do that container growth and shrinkage manually. I also showed you one growth of one box through Ansible. So that one box we were able to add yesterday, I think the last day, I was able to expand our cluster and add it one more machine into the cluster using manual scaling of containers and Ansible scaling of machines. That's what I was able to do. But as this load goes away, you will see that there is a need to save money and not have that many of these machines running here and here and here and more. There is no need to run these machines anymore, that many of them. Maybe just one is good enough. And so you just leave with one. And that is how auto scaling behaves. It shrinks by itself, auto scaling. Automatically grow, automatically shrink based on incoming work. If it is a lot of work, you grow, both directions. Or directions are irrelevant. It's just the picture is showing you some sense of direction, but actually directions are irrelevant. You can have the machines any way you like, physically organized. They just need to exist and be able to produce the output expected of an upload web server is to dump the movie here and put a to-do list item. That's the idea behind these upload servers. So now you know that there is video here sitting Infinity War, sitting right there in the raw format in the bucket. You know that because this upload server did it, put there. And now you also have a work item. So a work item is typically done in what? There is this thing called a to-do list, right? A typical to-do list is very, very similar to what you think it is. Basically, think of it as a bin where you put an item in there and you put another item on top and you put another item on top and another item on top, and like that. You keep stacking them. It's a stack of things to do. And you just accumulate them one on top of the other. And then when you are doing it, you get one of the things out and say, okay, I'm done with that thing. Now I'm done with that thing. And you see you're shrinking the number of things you have to do. And so that is how you eventually are done with the to-do list. Eventually it will shrink down to 0. And then you call yourself done. That's exactly what a to-do list is. Now you can store these lists in any kind of queuing system. Queue. And the example here is showing you a job queue using the Amazon the simple queuing service, SQS. SQS is, I think, an implementation of RabbitMQ, which is an open source product. Maybe there are some variations to it. I don't exactly know how they built this product, but let me tell you that there are many, many such products in the open source that will take and create a queue for you very easily. Just say Docker run RabbitMQ, and you have a queue. You can use it. It's as simple as that. Or you can use SQS, which is also equally simple. So it's up to you as to what you want to do, whether you want to use a ready-made service or run your own service using your own job queue. It's really up to you. Having said, this queue is what is going to keep track of things to do. It is your to-do list. In that list, you will have an action item. One of them will be to process and transcode, Infinity War. That's one of the actions. There may be multiple other movies coming in and there'll be multiple other items. And that's your to-do list available to you in your queue. That's the function of your web server upload servers, these guys. Okay, next. Job of this guy is this guy is practically complete because he or she or that robot uploaded the movie coming in, and then he can go home. His work is done. I mean, it's a robot, so he doesn't go home. So okay, the upload action finished. Next, you have a queue item sitting in there. And our goal will be to make sure that this queue is down to 0. All these items that are stacked up in the queue need to be handled and be done, but they're not done yet. So somebody has to do the thing. Who will do it? The doing action is the processing pipeline. That pipeline is also showing you in form of an auto scaling group. Again, it grows and shrinks. And it grows and shrinks based on what? There is no dude here. and there is no robot uploading anything. So how will you grow and shrink this processing pipeline? Anybody? What logic will you use to grow the processing pipeline? Or maybe shrink the pipeline, shrink the processing pipeline, or grow it.
Or like same logic what you use in databases, like auto shrink kind of thing. Auto shrink, so whenever you need it, it increases. Whenever it's not needed, I think it shrinks.
Yes, the concept is exactly right. But the trigger, like what will be the trigger to say, okay, I now need one more machine in the processing pipeline. The trigger is when you have a new machine, new movie coming in, you have it being processed by this machine and it's taken care of. You have more movies coming in. At some point, you have to make that decision that I cannot handle these many movies with one box. So I need one more box. At some point, you have to trigger. And this triggering action has to happen right here in the auto scaling group. The trigger decides, okay, I pull the trigger, I get a new box. What is the trigger? It trigger depends on how many movies are coming in. That's what decides this trigger. When will I get one more box to help me upload movies? That is the trigger. The question to you is, what is the trigger for this guy? You know the trigger for this guy. It is the number of movies coming in. That's the trigger. How many movies? More? Okay, I get one more. More movies? Okay, one more. You get a growing auto-scaling upload web servers. They will grow because you have lots of movies coming in. So you need to handle all of this. So you should just do it. Grow. That's a trigger. So I'm asking you for the trigger for the processing pipeline to grow. What will that trigger be? The movies are already in. They're uploaded, they're sitting here, and the to-do list item created. Now what? What will the trigger be for the processing pipeline to grow? One more box to finish the processing quickly. What is this processing pipeline actually processing? It is processing this movie stored here, Infinity War, raw. And it is converting it into all the other formats for iPhone and Android and this laptop and that laptop and 4K and 5K and oh my God, all those variations. That raw file needs to be converted into all the target devices so that it will correctly play on target on a variety of targets, depending on whatever the user wants to do after 4th of July. Not right now, after 4th of July. So that is what the processing pipeline is actually processing these videos. And that action item is coming from the to-do list action. So there is a movie called Infinity Wars. There is this movie called Deadpool 2. There is this movie called Old Movie from India. And by the way, I don't watch movies. I don't even know names of the movies. That's another challenge. I actually don't use Netflix because I don't have a need to. I don't watch movies. Having said, I have an account because T-Mobile gives it to me. So these movies are accumulated in the to-do list. The files are sitting in raw here. Now I'm giving you hints to tell me what is the trigger. The trigger will be the to-do list. What you really want to do is call these things done. So my to-do list goal is to finish processing as quickly as possible. So I can say that my processing is done, 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 done. Infinity Wars, done. Deadpool 2, done. This movie, done. That's what I want to do. That is the to-do list sitting here. And so this processing pipeline will actually take from here and process the to-do list down to 0, so that there is no more processing needed. I am done with processing. My to-do list is 0.
So
And then I can
question.
rest. Yes.
So here on the servers, auto scaling, and in the processing, the servers are increased and decreased auto depending on the demand. So is that like even for Amazon, the billing cycle for Netflix also runs that way? Like,
Yeah.
if you are using more servers, you pay more.
Yes.
Is that way it works?
Yes. Yes. That's the whole reason why they use cloud.
Uh-huh.
The
Okay.
whole reason why you pay as you go.
As you go.
Don't pay $10 million up front, but you pay only for 2 machines when I need only 2. When I need 10, I get 10. When I need 1,000, I get 1,000. When I need 2, I get 2. I pay for 2. That's the whole point of using cloud, is to save money. Even for Netflix, even for you, same thing. That's the whole point, is to save money. So I am actually further expanding this idea right now, is to tell you that this queue that we are talking about needs to be at 0 all the time, because that's when you will call your work done, when it is at 0. And so you want to process the Infinity War movie and other movie and all that, but you want to process it. The processing has to finish, meaning the queue has to shrink down to 0. And the queue is the actual customer for this auto scaling group. And if the queue length is too high, that should trigger creation of another machine. If the item is really lot of items sitting in the queue, process this, process that, process this, X, Y, Z, lots of movies uploaded already and sitting here waiting for a processing action to happen. And there is one machine sitting here processing this one and this one and this one. That's a bad idea, because at some point you will miss the deadline here and you will not be able to produce the output for Infinity Wars in time for the July 4th. And then you are screwed. And you don't want to get screwed, so you finish processing quicker. So you put more machines, because your queue is a long list of to-do items, and you want to shrink it to 0 as quickly as you can. So you add more machines. And by doing that, you are able to process your queue quickly, like that. And you're able to shrink your queue like that and like that. And the last 2 remains. Okay, only 2 remains. I can shrink some of the machines, and only 1 can do. So 1 machine can handle these 2. Fine. That's what I will live with. 1 machine doing 2 items, and they are also done. And now what? What do I do with this machine? My queue is 0. 0. All the processing is done. Now what do I do with this machine here?
That might be only the juice, like a minimum.
Yeah, all these are juices. All these are juices. All the machines are juices with just enough needed to get the processing complete. Just enough for upload to complete. Just enough for processing to complete. So there is one box.
Keep it inactive.
Sorry, I heard you say keep it inactive.
Yeah, keep.
Yeah. So even if you keep it inactive, you still get the bill. You know that, right? Even if you're not using a machine, you still get the bill. So why keep it inactive?
Kill it.
Kill it. Yes, exactly. Exactly. When you have nothing to do, you kill the machine, and your processing pipeline is gone. You don't need it. You will bring it back as soon as there is 1 item. Bring the machine back. It doesn't cost you a thing. That's the idea behind auto scaling, is that there is nobody here, so your machine should also be gone. When you have somebody here, like this guy, then you create one machine. And that machine is actually just one movie called Infinity Wars. And that movie needs to go out on July 4th. And so today is May 2nd. And so my question to you is, what kind of machine should I get? The question is, and I'm talking slightly on economic and the business aspects of using cloud. That's why you will see some of the discussions are encompassing a variety of things together in one screen, in one image, one picture illustration. I'm mixing a couple of economic and business aspects in here as we discuss, which are also important to understand. For example, kill the machine when you don't need it is an economic decision. When you have only one movie to process called Infinity Wars, and you have that one movie, and that's a to-do list item, and it has enough time available to you, May 2nd and July 4th, enough time. What kind of machine should I get? Like here is AWS instance type. Lots of types. So here, what do you think I should get? Biggest one, smallest one?
The cheapest one.
Nothing.
Cheapest for the job. Yes, that is the right answer. Cheapest to get the job done. Beautiful answer. Beautiful. The cheapest.
But why do you need that also?
Because there is one machine, there's one movie to be processed.
But we have a time till July 4th, so maybe
Right.
we can get it.
Yes. So go on, keep going. You're thinking.
You can get it only like July 2nd and process how much ever time you need for testing.
Yes.
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 You can get it. That's it.
Yes. Yes. So what I would like to tell you is that there is another idea that I have never discussed before when I was using the Amazon cloud. And let me just go there to show it to you. You will see it now. I kind of deliberately skipped it. When I was using Amazon cloud in the past with you, I deliberately skipped over some of the portions because now is the time to discuss that. So let me show it to you again. Here we go to EC2. And I will go launch a new machine. Now this machine will be typically launched through automation, so you don't launch it by hand, but I'm just launching it right now by hand. Select. Now here, I select and decide that maybe this M5 4 extra large is a decent enough size. So that's the choice that I made. It's a big machine, decent size, not super expensive, and it's there. Maybe I can do with M5 large. That's also an okay machine. Any of these two. So just pick one of those guys. So I'm picking the M5 large, for example. So I select that one. And then I go next. And then I say I need one machine. And so I get that one number right there. And then comes the interesting idea. The idea is this. And I never discussed this thing before with you. But do you know what this thing is? When I request Spot instances, I suddenly see something very different here. I see that I can get a machine for 3 cents. 3 cents. 3 cents. Typically, if you want to get a M5 large machine, the pricing is, let's go find out. M5 large machine pricing is Linux machine M5 large. The price M5 large. The price is 9 cents. Why is Amazon giving that machine to me for 3 cents? The price is 9 cents right there. Why is Amazon suddenly become generous and offering me a price of 3 cents when the machine is in M5 large is supposed to be 9.6 cents? So is Amazon being generous? Are they opening a charity? What is going on? Do you know?
Since it's an ongoing business, that giving a cheap, it's a spot instances. You are putting aside, you're reserving, you're booking it.
You're thinking in the right direction, but you're not using the right words. So I understand what you're saying, but let me help everybody also understand. The idea here is not reserved, but spot. The right way to think and explain to everybody so that everybody else also understands is to use the word eBay. You know, you are bidding on eBay. And when you have an item that is typically, like say an iPhone, for example, and you want to buy an iPhone, the iPhone is available in the market for $799, and you find an iPhone, somebody's selling it for $349. What do? You bid. How much? $351, something like that, like some small number, and you're bidding it. And what happens? If somebody else comes along and bids higher than you, will you get the iPhone? No, you will not. This guy will get it. What if somebody else comes along and bids higher than that? $353. What happens to this guy? No, they will not get it. That's the idea that is happening here. Is you have to actually go and bid a maximum price you are willing to pay. And so I'm going to bid right now 0.0331. And I deliberately chose that number, which is slightly lower than this number. That's the amount I'm willing to pay. And I will now go launch it in my default VPC. Like that. And I go review and I say that launch. So when I say launch, what do you think will happen? Let's go back to the previous screen. When I actually launch this machine and I choose my maximum price to be 0331, will I get a machine?
No.
No. Why not? Because I'm bidding lower than the lowest. If I really, really want a machine, I should bid higher. I might get a machine at that time. Might. And if I want to spend like full amount of money, I will go and not even bother request spot instance. I will immediately get a machine, and I promise to pay 9 cents, 9.6 cents. But spot instances are a cheaper way to get the machine, but you don't really know whether you actually get it or not. And another twist. The twist is kind of scary twist. In that, you might actually be given a machine to do the processing for this Infinity Wars movie, and you get that machine allocated for a price of 0333 that I just bid, right? So I pay that money. I might get a machine actually. They might give it to me because the price is 0333, so it is higher than this number. So I'm likely to get. If I want to just guarantee getting a machine, I should bid slightly higher than that, maybe 4 cents, like that. I'm very, very likely to get a machine in that case, very likely. However, these machines come with a caveat. The caveat is, anytime Amazon wants the machines back, what they will do is delete the machine. They'll delete the machine and take it away anytime they feel like. The question I have is that a good idea for our use case?
Yes.
Why?
Because you can build an algorithm, like, depending on your deadlines.
Yes, got it. You got it. Yes, exactly. We have ample time. July 4th. Today is May 2nd. If this machine goes away, 0334 machine, I spend 0.04, and the machine goes away, I don't care. I'll start another machine. Fine. It doesn't matter. So that's the caveat with these spot instances, is that these machines are available for you for cheap. I mean, substantially cheap. You see the price in the market is 9.6 cents in the open market, which is called, price is called, let me get the right language for Amazon. The language Amazon uses is called on-demand price. On-demand price for an M5 large is 0.096 something, some number like that. And the spot price right now at this moment is right. That's the difference. So you're getting substantially cheaper machine, but it comes with a caveat, which is they can take away the machine anytime they feel like. It is kind of sort of like this, that, but why would Amazon actually, let me ask you this, why would Amazon reduce the price so much? I mean, imagine it's like 70% discount, roughly. Yeah, 67% discount. So it's a hefty discount. Why are they able to offer such a heavy discount and still survive? What is going on?
It's the same logic what Netflix is applying. Amazon is also applying the same thing. When there is a demand is more, they'll charge more. When the demand is less, they will give it for cheaper.
Yes, that's the idea. I'll give you the idea in a different fashion. I'll give you an analogy of the same idea. Imagine here, you are at the Seattle airport. You are the station manager for Alaska Airlines. The flight AK501 is going from Seattle to San Jose. And there are 3 seats vacant. You are right there, or rather, not you, me. I am right there. This is me. You are the manager of Alaska Airlines. And by manager, I mean you can decide what to do. You can make judgment calls and make decisions for Alaska Airlines. And I am there, happen to be at the gate somehow. Forget the security aspects. I'm just showing up at the gate without a ticket. And I want to buy a ticket. The ticket typically is, say, $200. That's a typical Seattle San Jose ticket, low price. And I am there, I want to go to San Jose, but I don't need to go to San Jose. So I just am checking if you let me sit on one of the 3 seats that are vacant. Because the point is, if the plane flies off at like 10 a.m., when it does, it flies and it goes with 3 vacant seats. So the price of a ticket will suddenly become 0. At that point, before 10 o'clock, the price is not 0. But at 10 a.m. and after, the price of that seat, which has already flown, is worthless. The plane has gone. So the price of the ticket is 0 after 10 a.m. But before, that's the question. How much should you agree to sell this one of the seats to me if I am here telling you, hey, can you give me a discount? How much do you think you should offer me? So this is like, 10 a.m. and this is the same day. This is the day before, the 2 days before. And so the prices are typically very expensive a couple of days before the actual flight. It may be $700, who knows, 3 days, 2 days before. And the price is slowly going down. Maybe it doesn't go down, depending on dynamic availability and demand and supply. But at this point in time, which is just before 10 a.m., I show up and ask you for a discount. The question to you is, how much below this $200 price should you be letting me get in on the plane before it flies at 10 a.m.? How will you go about deciding whether to give it to me for $10, $15, $100? How much? How do you decide that thing? That's kind of sort of what Amazon is doing. The regular price is $0.096. They want to give it to me for 0.0033. Substantial discount. So if you were the manager, how much will you charge and why? How much should you charge? The goal is to make profit. You should still make profit, even though you are giving me discount and letting me sit on this one of the 3 vacant seats. You should still make profit, not a loss. That's a requirement for business. So you have to make profit. You give me discount. How much low can you go? What will you cover? What will you take into account? The idea is marginal cost of operation. The marginal cost is the extra cost added when you add one more of something. One more passenger. 3 vacants, now it is 2 vacant. One more passenger added. How much is the extra cost that the airline, Alaska, is actually adding on top because I now am in the plane? What is that cost? Extra cost.
The fuel.
So am I that heavy and big fat that the fuel will be spent?
All matters because fuel and the the complementary.
I agree. Fuel does matter.
Drink.
Yeah, I agree. Yeah, fuel, $10, $20 fuel. Let's go. Yeah. And drink. Yeah. Drink, maybe $5.
Yeah.
And they will expect me to finish the entire bag of peanuts that they give me. So I will finish the whole bag. So $5.
Yeah. I think.
What else? Maybe cleaning, toilet cleaning, $10. Right?
Yeah. Marginal cost of operation. Yeah. Maybe.
Exactly. Right. So we are looking at like $40. So make profit $10 and charge $50. That's a way to think about. That's a way to think about this thing. So when I charge $50, I still make some profit. And this is for cleaning, this is for peanuts, this is for drink, and this is your fuel. And then you still make profit. And you let this guy in. And I fly. And there are 2 vacant seats. If you don't let me into the plane, you lost $10. Because you did not make $10, right? That's how the opportunity is lost. You could have made 10 and you did not. That's a loss. So that is what Amazon is doing here, is what they have is a bunch of machines in their cloud, a ton of them. And if there is nobody to use it, it is very, very similar to the plane flying away with 3 vacant seats. When there is nobody to sit and you want to fill it up. You want to have your entire cloud full of load or workload. You want to get people to just run something. Because if you don't run anything, it's a total vacant seat. And you're not even making those $10 that you could have. That is the reason why Amazon is giving you the idea, which is spot instances. That's the whole idea underneath, under the hood. That is why it is so cheap. Because otherwise, they will not make that money. So why not make some money? That's the whole idea. So now here, if you look at this screen again, come on, adjust the screen size. There we go. And let's look at this same idea of spot instance pricing on a dynamic scale in another location. There is a place to find these dynamic prices, and we'll go there and see what the pricing of these spot machines are. So there are these spot request, and there is a place to find a pricing history for a machine type of M5 large. For the last 3 hours, the price has been these numbers: 0332, 0351, 0342, different availability zones have slightly different prices. for the last 3 hours, that has been the case. The on-demand price is 0960, as you already know. Now let's go look a little bit history. So one day, what happened today? Let's see what happens today. Nothing, same thing all along. There's slight variations in the numbers. If you watch these numbers here at the bottom, and these numbers, watch them as I move my mouse. You see some variations coming in. At time of day, as you will see some trickle, the numbers change a little bit depending on bidding activity happening. You will also see, if I go 1 week, what's the change? Not much. It is pretty much available for dirt cheap. An M5 large machine available not for 9.6 cents, but 3 cents, 3.5 cents. Dirt cheap price. If you now expand it to 3 months, let's see what happens. Here, there is some higher price slightly. Before that, it was even lower, 316, 0316. You see that number? It has been steadily low. Now this is a sign that Amazon is underutilized. For the last 3 months, Amazon has been consistently giving you a 0316 price on spot. That means it is underutilized and overspent on their infrastructure. Therefore, they are discounting it substantially below the number down to this number, below the on-demand price down to this price. And that has been steady for the last 3 months. You will see occasionally for some other machine types, when I clear it and go change the machine type in question, let's go see some other expensive machines, especially the Bitcoin mining machines, which are, what are they called? GPU instances. So let's go look at that machine. That will show you some interesting things. Let's go see that. GPU instances, click. And there it is. See what happens. A peak. The usual price of this G28 extra large machine is $2.60 on an on-demand basis. However, right now, the price is 78 cents. A couple days ago, April 8th, maybe a month ago, April 1st, oh, it shot up to some high number. What was that number? $2.14. What's the on-demand price? $2.60. Why did it shoot up? Simple answer, market demand. People wanted that machine, they bid it higher. Then people did not want it, it went down. As simple as that. For some reason in this period of time, between March 24th and April 8th, there has been exotic demand for this particular type of machine for some reason that I suspect to be Bitcoin mining of some sort or some other activity. I have no idea what's causing that demand growth, but it is there. You see some other machine types here. Let's go see this machine type. And at some point you will see some really weird situation, like right now. The price of this machine usually is $24.48. And right now, this machine is available for $7.34.
Trade quarters.
Right there, $7.34.
Not when we go bank, we can do that.
We go where?
And if you look at that price here, $7.34, if you include that, the price suddenly grows as you enter this data, March 16 all the way. And at some point, the price is matching the on-demand price during this date. So March 24th all the way through April 18th or so, the price has been steadily 24.48 all along in this zone, in this date zone, but only in the US West 2A. In other areas, in other 2B and 2C, it has been low. And this is primarily an action taken by Amazon to clean out cheap consumers. Consumers are people who are bidding low on spot instances because they want to make room for full paying customers. Customers like like these guys, they are full paying customers. They are not full paying customers. They are cheapos. They're saving money in spot instances. They know that it's okay to kick the machine out, but they are saving money by using cheap machines. So at some point when Amazon decides that they need to make room for fully paying customers, they do this action deliberately, and they will put the price, match it to the on-demand price, so that all the spot instance price machines will be terminated, and you just make room for full paying customers. If your infrastructure gets full, Amazon will typically do this action to flush the cheapos out, and they will be killed. And that's how Amazon will make room in US West 2A in this example, right there at 24.48. That's the exact on-demand price. It matched it. And so as soon as you match it, the cheapos will go away, and then you let them in again, because now you may not need it. So you have flushed it out, your infrastructure is reasonably available, and some availability is good to keep. So keep for the full paying customers, but the rest you can give it out back again as spot instances. Having understood this aspect, I would like you to know there is a third way of pricing these machines. And that way is what I will now describe. The two ways that we discussed are the pricing of on demand, which is the full price, and the pricing of spot pricing, which is like eBay style pricing, which involves bidding. Other people bid more than you lose. Lose as in you don't get the machine. You might actually win by not getting a machine, but win and lose are not the right words. When you actually get an allocation of a machine when you don't bid high, then you don't get a machine. You might actually win by not bidding high and thereby saving money and winning. So winning is a very subjective word. Having said, the third type of pricing, which is not on demand and not spot. The third one is called, I think in Amazon language, they call it reserved. And a reserved pricing is basically your guarantee to pay. You guarantee to spend some amount of money instead of 0.096 and instead of 0.033. You say that I come in and guarantee that I will keep on spending money on this machine, M5 large, for a period of 3 years. I guarantee that. I am reserving that instance for me, and thereby I promise to pay you a set amount for 3 years. Commitment. That is reservation. And by doing that commitment, Amazon might come back and say that, okay, I will give you a machine for like 0.46 and just enjoy. I'm just making these numbers up. But there is a way to find out what exactly that number is by going to Amazon and say, hey, can you please let me reserve an instance? And so Amazon will tell you that you can. And you can buy a reserved instance and say that I would like to get an M5 large, right? Where is that? M5? Hello, M5. There it is, M5 large. So M5 large, get me. Okay, search. So I search and I find it. And I see that a term commitment of 3 months, 36 months, search, 36-month term, 3-year term, right there, 1, 2, 3, all these are 36-month terms. I get, if I pay nothing upfront, so nothing upfront, search, and I get a effective price of 0.49, or this is the convertible class. So you can actually convert into another type if you don't like it. And this is the standard class, and the price you are able to get it for 0.42. And that is a good thing to get when you are actually, I overestimated it, so 0.42. is the number that Amazon will give you a machine if you promise to pay this amount every hour for next 3 years. Every hour, the hourly pricing. So if you make that commitment and you pay nothing upfront, that's the amount you will pay, 042. But if you decide to pay some amount of money upfront, then the number will even go even lower. For example, if you say that I pay some partial upfront or all of it upfront, and I pay nothing on a recurring basis, search, I get the numbers $968 upfront payment. The $968 I pay upfront, and I get the whole machine for me, for dedicated to me, reserved for 3 years. And I don't have to pay anything. I just pay right now upfront. Take it, reserve. That's the idea here. One quantity, $968, 36 months, all upfront. There is a partial upfront option also available, in which case you can decide how much you want to pay, or rather, they'll tell you how much you pay upfront. Like here is the amount you pay, $515 upfront, and then you keep paying a price of 20 cents. No, not 20 cents, 2 cents. 2 cents an hour for 3 years, but pay $515 upfront. So like this, all upfront, pay $515 upfront, and then pay 0.02 on an hourly basis for 3 years. That's also another option. So depending on whatever your business situation is, you get to choose 3 types of pricing: on demand, spot, and reserved pricing. The numbers are understood, so they make sense from an economic standpoint. Similar to this, other clouds also have such pricing models. In fact, in Google Cloud, they don't have this idea of a spot instance basis, but instead they have what they call long-term use discount. They automatically give you this discounted price if you use the machine all month long. So if you go back to something like Google Cloud, you will find this thing right up front in the pricing table. There should be a pricing method of sustained use discount mentioned somewhere here. So let's go see sustained use discount. Sustained use discount from Google. It will pop up, and here it is. So the idea behind sustained use is, if you keep using the machine on a full month, they will just give you the effective discount of roughly about 30% at the end of the month. The more you use, the more discount you get. After a certain after a few days, you start getting discount accumulating, and at some point you will reach up to 30% discount, and you don't even have to ask for it. You just run the machine all month long and you get the discount right up front. Much easier to comprehend and don't have to go bidding. That's their model of pricing, which is, they call it sustained use discount pricing. There is one more type of usage that is similar to the reserved instance usage in Amazon, and that model in Google, they call it committed use discount. And here is similar to the reserved instance situation, where you are able to make a commitment that I will use the machine for next 3 years or 1 year, depending on what you choose. And then you select the machines you need, and yeah, you reserve the instance. I think that's pretty much it. So you get up to a 57% discount in return for committing to a usage for 1 year, 3 years. So when you actually make that commitment, all you're really doing is signing a contract with Google that you will use a machine for 3 years, and they will, as a consequence, give you a 57% discount, which is a good deal. Pretty similar to this idea. Reserve pricing, they call it committed use discount. And they don't have a spot pricing method, but they have the automatic discount given to you based on sustained use. They also have this expiring scenario, which is where the machine will just disappear from you. That scenario also they have. They have a different name for it, where the machines will just disappear on you. That method is called, what is it called? I don't remember the name, but I'll look it up and find that for you, and tell you what these guys call it. And same with Microsoft Azure. They have a slightly different way of pricing. Their pricing is slightly more complicated. But let's go quickly look at this also. And what I will do is, when we run the session next time, we will actually do an exercise on auto scaling, and you will actually see these things automatically growing and shrinking based on some triggers. That's our exercise coming up that I was going to do today, but I think we ran out of time. So what I will do now is quickly give you a hint at the pricing from Azure. You already know the pricing from DigitalOcean and Vultr and a bunch of other clouds. The cheapest cloud you can probably find is none of these clouds, but the cloud is located here. This is the cheapest cloud you can probably get today, is the Scaleway cloud in Amsterdam. And this has exorbitantly low pricing, crazy low. So here, you get a 8 GB memory for 12 euros. And not only that, they give you they give you physical machines, bare metal cloud. That is also available. Where is that? Here. Bare metal, where is your bare metal cloud solution? Pricing, this is the bare metal pricing. So you saw bare metal already. The bare metal SSD cloud server pricing. This is not a VM. This is actually a machine, physical machine, 8 GB memory, 12 euros. And if you are getting a cloud server, you get it for even cheap. So 8 GB cloud server, which is a virtual machine, 8 GB, you get for 10 euros. That's their 64-bit machine. Six cores, 8 GB RAM, $10, 10 euros, not dollars, 10 euros. And this is the cheapest cloud I think I know of as of now. Amazon, the Azure pricing is here by product. And if you go look at the compute prices and look at virtual machine prices, the pricing is kind of convoluted. I don't understand it as easily as I find it at Google. So it's very easy to understand pricing. And Amazon they have these tools, but again, Microsoft has their own way of naming their machines, and they have so many of these burstable VMs and compute optimized general purpose and memory optimized. They're structurally similar to Amazon, but pricing is different. And you have to use a calculator, and each of these clouds will give you a calculator to calculate the estimated price of a given machine. Okay, I think what we do is finish up this Netflix discussion and do into an exercise the next time we run, which is going to be on Friday, on 4th of, is it 4th of April or May? May, yeah, 4th of May. So 2 days from now. And that's when we'll get together again. What I will now do is I'll stop the recording, and I am here for questions.